Welcome back, everyone, for another deep dive. Today, we're tackling the history of mathematics and philosophy, specifically the impact of Thales and Anaximander. And we've got some really interesting stuff to dig into today, excerpts from a textbook, and even a lecture that grapples with an idea so profound it gave even Immanuel Kant pause. We're talking about the isosceles triangle theorem.
It's amazing, really. When you think about it, we're not just talking about geometry here. This is about a moment that completely changed how we understand the world around us.
It's like that saying, the more you learn, the more you realize you don't know. This is a perfect example of that. To really grasp what we're talking about, imagine ancient Greece. Picture yourself amidst those grand marble columns surrounded by lively debates in the agora. You come across a group captivated by a man named Thales of Miletus, widely considered the first mathematician.
Though, to be fair, back then, labels like mathematicians weren't as clear-cut as they are now. Thales was a true polymath. He studied everything from the movement of the stars, trying to make sense of it all, and even predict solar eclipses. One prediction he made might have even changed the outcome of a battle way back in 585 BC.
Can you imagine that? Someone from over 2,500 years ago shaping our understanding of the universe? That's incredible. But Thales didn't just look to the stars. He also studied the Earth, attributing natural events like earthquakes to natural causes, instead of blaming it on the whims of the gods.
Now that's a game changer. That's where we see the early seeds of the scientific method observation hypothesis testing. It all goes back to thinkers like Thales who dared to look beyond the supernatural for explanations. And that brings us to the heart of our deep dive today, the isosceles triangle theorem.
As a quick reminder, the theorem states that if two sides of a triangle are equal, then the angles opposite those sides are also equal. Seems pretty straightforward, right? But the truly remarkable thing isn't the theorem itself. It's how Thales proved it. He used something called deductive reasoning.
Exactly. Thales didn't just say, well, it looks like it's true, so it must be. He figured out that if we begin with these assumptions, then logically this has to be true. That if-then, thinking that's the foundation of mathematical proof.
So we're not just talking about triangles anymore. This is about establishing a way to confirm truth, which is a big deal in any field. But what really highlights the significance of this is what a giant of philosophy, Immanuel Kant, said centuries later.
Even Kant, in his critique of pure reason, considered this proof a turning point. And not because it was elegant or anything, but because it showed the power of reason alone to uncover undeniable truths about the universe. It marked a profound shift in human thought.
It's almost like at that moment people started to realize, hey, we can actually unlock the secrets of the universe just by using logic.
And there's no better example of this than the relationship between Thales and his, well, I guess you could call him his protege Anaximander. He's often called the first scientist.
I bet there were a few people back then who might have argued with that title.
Oh, I'm sure. But what really sets Anaximander apart is how he took those ideas about natural explanations that Thales had and really ran with them. He embodies this whole idea of progress through criticism.
Which makes you wonder, does real progress even happen without questioning things? Without that back and forth, our sources seem to think it doesn't.
You know, a great example of this is Thales' belief that water was like the fundamental element of the universe in Anaximander.
Yeah.
Always the sharp mind wasn't so sure.
So what did he think? What was his take on it?
Well, he came up with his own theory, the apron.
Apron. Okay, now that sounds like something straight out of Philosophy 101.
It's actually a concept that still has scholars scratching their heads even today. Think of it this way. It's boundless. It's undefined. It's pure potential. Like, it's not water, not fire, but the source everything comes from, kind of like potential energy in physics, you know?
So not just some cosmic soup then. This apron thing goes deeper than that.
That's exactly it. Anaximander was searching for something more basic than water, something that could explain how water itself even existed. And the incredible thing is, he wasn't afraid to challenge his own mentor.
That says a lot about how open-minded people were in ancient Greece.
Right.
Our sources really emphasize the Athenian agora. It wasn't just some marketplace. It was this hub, this melting pot of ideas where questioning even the biggest thinkers was encouraged.
Can you imagine that happening today? Just walking up to a leading expert, let's say in astrophysics, and being like, hey, I heard your theory and I have a different perspective.
I mean, hopefully they'd be open to it. But that kind of open discussion, it's not exactly common now, is it?
And our sources argue that this difference in how people approached intellectual debate is really important for understanding why ancient Greece became such a breeding ground for science and philosophy.
It's almost like those marble columns weren't just holding up buildings, huh? They were holding up this whole different way of thinking, where debating and questioning that was just the norm.
That's a great way to put it. And here's where things get really interesting. Our sources point out that other civilizations around the same time as ancient Greece, like China, they had their own golden ages too. Advanced tech, sophisticated governments, the whole nine yards.
But they didn't have that Thales and Anaximander thing going on, right? The constant push and pull of ideas.
And that raises a really intriguing question. Could this difference in how they approached intellectual debate explain why the scientific revolution as we know it happened in ancient Greece? It's a bold claim for sure, but it definitely makes you think.
Yeah, it shows how knowledge isn't static. You need the right conditions for it to grow and evolve. Just like a plant needs sunlight, maybe intellectual growth needs that oxygen of debate.
Yeah.
The freedom to question the norm.
That's a powerful thought. Especially these days, we're bombarded with information constantly, different viewpoints, claims to truth. It's easy to feel overwhelmed.
Totally. And even worse, to just accept whatever we read or hear without really thinking critically about it, without channeling our inner Thales and Anaximander.
Exactly. And that's why this deep dive, even though we started with something as seemingly simple as triangles, it really resonates. It reminds us that knowledge starts with a question, a challenge, a refusal to just accept things at face value. It's about cultivating that willingness to respectfully disagree, to push the boundaries of what we know.
So as you go out there and explore the world of Thales and Anaximander and the origins of critical thinking, remember it's not just about taking in information. It's about actively engaging with it, questioning it, maybe even starting some lively debates of your own.
Who knows? You might just spark the next big breakthrough.
That's all the time we have for today's deep dive, but the conversation doesn't have to end here. We'd love to hear your thoughts on this fascinating topic. Head over to our website or social media pages to share your insights and keep the discussion going. Until next time, keep those minds curious and don't be afraid to challenge the status quo.